Now let's go to rule 7. Rule 7 is the quotient rule. The quotient rule. What does it state? If y is equal to u over v, remember the product rule was multiplication. The quotient rule has to do with division. So if y is equal to u over v, where u and v are functions of x, then dy dx will be equal to v du dx, that's v times du dx, minus u dv dx all over v squared. Over v squared. So what we are doing is, in this case, you keep v constant first, and then you need to multiply with the derivative with u of u with respect to x, and then you subtract, you keep u constant, and you need to multiply the derivative of v with respect to x all over divisor squared, that's all over v squared. So let us look at an example. If y is equal to sine x over x squared, then what is dy dx? To solve this, let us try to get all the things we need to put in the formula just as we did in the product rule. So in that case, we have that v is equal to x squared. Okay, then we also have that the v, based on that, the v will be equal to 2x, based on the second rule of differentiation. The v dx will be equal to 2x, and then u in this case is going to be equal to sine x, so that the u dx will be equal to cos x, based on rule 3. Good. Now that we've got that, let us bring everything together. We have that dy dx is going to be equal to v du dx, and what is v in this case? X squared times cos x, that is du dx, minus u is equal to sine x, and then dv dx is equal to 2x. So that's going to give us sine x times 2x. Please let us memorize this formula and the one for the product rule. Memorize this formula. It is your key to understanding or to solving differentiation involving quotient rule and product rule. So please memorize them. The formula for product rule, in fact, it is necessary that you write your formula down first. Once you can remember that formula, once you write it down, you should be able to easily solve the problem. So we have that all over v squared, and we said that v is x squared, so all over x squared raised to power 2, that's x squared or bracket 2. Excuse me please. Okay, so we have, from that, let us simplify the equation. Dy dx is going to be equal to, I can see from here that x is common and can be factored out in the numerator. X is common, so dy dx is going to be equal to, I can open the brackets. If I factor out x, I would have x cos x minus 2 sin x, bracket close, times x, bracket close x. So I factored out x from there, all over, based on the law of indices, we add these two powers, 2 plus 2, because they have a common factor. So 2 plus 2 is equal to 4. So that will be x to the power 4. Now, I can use x to divide x to the power 4. If I do that, x will cancel out itself, and then x will cancel 4 to have a remainder of 3. So that dy dx is going to be equal to x cos x minus 2 sin x all over x raised to the power 3. Very easy. Okay, let's do a more difficult one, which will lead us to something, to another concept, because some people may be asking, we looked for the differentiation of sin x, and we did that of cos x, but we didn't talk about that of tan x. Our next example would help us to answer that question. So let's look at this example. If we have y is equal to sin x over cos x, let's take a little hint here. Sin x over cos x is equal to tan x. That's based on the law of trigonometry. Sin x over cos x is equal to tan x. So what is dy dx? Remember, based on our quotient rule, we have sin x, one function of x, divided another function of x. If we are able to know the derivative of sin x over cos x, then we are able to know the derivative of tan x. Okay, so v in this case is equal to cos x. So dv, based on rule 4, dv is going to be equal to minus sin x. And then u in this case is equal to sin x, therefore du is equal to cos x. Now let's put all these our keys into the formula to open the solution. Okay, so we have that dy dx will now be equal to, what is v? We know that v is equal to cos x times du dx is equal to cos x also, so that will be cos x times cos x minus, brackets open, because another minus sign was introduced when we did differentiation of cos x, minus, bracket open, sin x times minus sin x, sin x times minus sin x, bracket close, all over v squared. What is v? V is cos x, so that will be all over cos x squared. So if we simplify this equation here, we would have that dy dx will be equal to cos x times cos x is cos square x, minus sin x times minus sin x is minus sin x squared. So minus sin x squared all over cos squared x, minus sin squared x, sorry, all over cos squared x. So we have cos squared x minus, bracket open, minus sin squared x over cos squared x. So dy dx is going to be equal to cos squared x minus times minus is plus, plus sin squared x all over cos squared x. Now let us take another hint. based on the law of trigonometry, we have that cos squared x or sin squared x plus cos squared x is equal to 1. Remember, addition is commutative, so cos squared x plus sin squared x is the same thing as sin squared x plus cos squared x. So dy dx in this case will now be equal to, you can simplify that to be equal to 1 over cos squared x. Also, let's take another hint. This particular solution is full of hints. Let's take another hint. 1 over cos squared x brings us to introduce this hint. We should know that 1 over cos x is equal to sec x. In the same vein, 1 over sin x is equal to cosec x, and then 1 over tan x is equal to cotan x. But for our example, let us take note that 1 over cos x is equal to sec x. So if 1 over cos x is equal to sec x, then dy dx, which is equal to 1 over cos squared x, will be equal to 1 over which is equal to 1 over cos squared x will be equal to sec squared x. So dy dx is equal to sec squared x. So therefore, remember our first statement. If you are able to look for the differentiation of sin x over cos x, then you are able to know the differentiation of tan x with respect to x. So d tan x, or dy dx for tan x, is equal to sec squared x. Please, like I said before, try to memorize the formulas that we've given, because they are the key to your solving problems involving differentiation. In our next class, we'll be looking at more difficult examples and other rules involving functions of functions, differentiation involving functions of functions. Please do well to subscribe. Have a nice day.